Okay, in this question we have a calculation to do to figure out the molar mass of hemoglobin. Okay, so with this one, we're given a situation where it says that every molecule of hemoglobin combines with 4 molecules of oxygen. Okay, so off the bat, we know that the molar ratio of this would be 1. Just gonna put HEM to 4 oxygen. Okay, so we want to remember that because we will use that later on in the process of solving for this. So it says it's observed that 1.51 grams of hemoglobin combines with yada yada yada. It doesn't tell you the exact amount in grams. So what we have to do is, in here we're given a volume, we're given a temperature, we're given a pressure. So with that information, we know that with those three things, we can move forward with the ideal gas formula. So our pressure, and again, like everything, I'm going to convert everything to atmospheres. So we have 743 torr, which would be a 977 atmospheres. Our pressure, our volume. Okay, we have 2.3 ml. Okay, so we need to convert this to liters, so we know this decimal has to be moved over 3 places to the left. So I'm going to add some more zeros, 1, 2, 3. So super small volume. It's our volume. Number of moles is what we're solving for. Why are we solving for number of moles? Well, the number of moles is going to tell us how much oxygen will bind with hemoglobin. So we need to figure out the number of moles, and then the R value we're going to use 0.82 because our units that we're using liters, atmospheres. So we're going to use 0.082. And then my temperature, 37 Celsius, would be 273 plus 37, which would give you 310 Kelvin. So if we do our calculations now, 310 times 0.082, 25.42 N equals 0.977 times 0.0023. 0.00247. Divide these two. Divided by 25.42. Okay, so we get number of moles of oxygen that bind to 1.51 grams of hemoglobin would be 0.000088. Now, moles of oxygen. Now, we're going to go back and we're going to take this mole ratio right here, and figure out how many moles of hemoglobin that would be. So 4 moles of O2, 1 mole of heme. Okay, so now that we have this set up, we're going to do, it's going to be 0.000088 divided by 4. So we'll get 0.00002 moles of hemoglobin. Okay, so if this is the amount of hemoglobin, if 0.00002 moles of hemoglobin is 1.51 grams, and we can take 1.51 grams and divide that by the number of moles, and what that'll do, that'll give us our molar mass of hemoglobin. And we will get about 68,636 grams per mole. Okay, which, depending on how you round those, because we have such small numbers here, like there are numbers after this too. So anyway, so what you'll get is something around 68,000 grams per mole, which would be the third option on here. So again, what we did in this question, we found the number of moles of oxygen within this using these variables, and then we took the number of moles of oxygen, and then we looked at the mole ratio, used the mole ratio to determine how many moles of hemoglobin were used, and then we found the molar mass of hemoglobin by dividing the amount that was seen to react by the amount of moles that would be, which will give us the molar mass.